All right, this is lesson 5. And the first example problem is on my board here. I'm going to go ahead and start just building the model. So I have 2y's, okay, let's start with, plus 1/6 of y plus 4 is equal to 20 plus 5/6 of y, okay? So there's my equals. Okay, so I see an easy simplification right here. I think I'm going to take both those pieces off, and now I have this. And I'm going to take the 4 off here, take it out of one of the 10s. If I take 4 away from a 10, I get a 6. So now I've done a little bit of simplifying here. 2 whole y's is equal to 16 and 4/6. And this is where, in order to subtract 4/6 from both sides, I really need to substitute, okay, 6 of these pieces here for one of my y's, all right? So I've got, make sure I did that right. There we go. So one of my y's now, I've substituted 6 of these pieces. So I'm going to take away 4, then I need to take away another 4 here. Okay, so those will be taken away. I do still have a mixture of pieces here, and in order to make it a little bit easier to count, it would be easier if I did, in fact, substitute 6 more of these pieces here for my y, okay? And so now I just have 6 on the left and I have numbers on the right. So how many do I have? I have 8, right? I have 6 plus 2. So it does mean that I've got 16 divided by 8. Each green piece, each 1/6 piece has to equal 2, okay? And if each of those equals 2, then the whole, being 2 times 6, a whole y has to equal 12, okay? So I'm going to go ahead and check that now. So if y is 12, 2y is 24. If 1/6 of y is 2, I'll substitute that in, plus 4 equals 20 plus 5/6 of y. Each sixth is worth 2, so that would be 10. 5 times 2 is 10. Okay, so now I'm just basically just doing this substitution here, right? For what I now know is the y value. This simplifies to 26 plus 4, which is 30, which does equal 30. Check. I've done it correctly. We'll do example 2. All right. 2y minus 2/3 of y plus 4 equals 18 plus 2/3 of y. All right. So here we're going to be working with thirds. Because I can see all right away that I've got thirds and thirds, why not just build even my y's with thirds? Okay, so I'm going to just do my 2y here with thirds. There's 1. And this will be my second one. Okay. And then it says to take 2y and then subtract 2/3 of y. So I'm going to take those away. So this represents that, okay? Plus a 4, right, is equal to 18 plus 2 more thirds of y, okay? So this one, if you set it up this way with not having mixed pieces, or we're talking about fractions with mixed denominators, it's going to be easier to solve my equation. So I'm going to take away 2/3 from the right, take away 2/3 from the left, and that leaves me just with my thirds on the left. Then I need to take the 4 away from the 8, which will leave me with a 4 on that side. 2/3 equals 14. Well, that means each 1/3 piece has to equal 7. 7 plus 7 is 14, and therefore the whole y piece has to equal 7 times 3, or 21. 3 of these make a whole. Okay, let's check go ahead and check our work here, see if that value of y makes this true. Okay, if y is 21, 2y is 42. Okay, minus 2/3, that's minus 2 sevens, so that's a minus 14, plus 4, does that equal 18 plus 2/3 of y? That'd be 2 times 7. Okay, and so on this side I get 32. On this side, if I say negative 14 plus 4, that means minus 10, right? Then that means 42 minus 10 is, in fact, 32. 32 equals 32. There's a check. All right? So those are two examples. It's just really what you've been doing before, just a little bit more complicated, a little bit more going on. And just be careful when you're dealing with different types of fractions. It just gets to be easier if you express everything in the same denominator. Again, I have a sheet of 4 problems for lesson 5 that will be the new material, and then review work for you for your homework today. All right?